Great job, you guys. Okay, now let's review. First, we learned the difference between weather and climate. Then, we learned how weather is produced by several factors like heat energy and moisture. Next, Dr. Graham Stevens told us how the CloudSat satellite will be able to help improve weather prediction across the globe. Ah, merci beaucoup.
Je vous en prie.
Now let's focus our attention on aerosols, climate changes, and Calipso. Now for that, we're going to head to the Space Agency of France, or CNES. What NASA is to America, CNES is to France. So let's go speak with Dr. Didier Tonray. He's a principal investigator of Aerosol and a co-investigator for the Calipso mission. Calipso is a satellite that's being built by both France and the United States.
Merci, Jennifer. The climate of the Earth has not remained constant through the course of time. It has changed. In general, living things have affected changes in climate, and changes in climate have affected living things. Working in groups, see if you can answer the following question. What are some reasons why our climate has changed over time? Teacher, you may now pause the program so students can answer the question. From report of increasing temperature, we think that the Earth's climate is maybe changing, but the processes behind the changes are not as clear. Two of the biggest uncertainties in understanding and predicting climate change are the effect of clouds and aerosols. The Calipso, or Cloud Aerosol Lidar and Infrared Pathfinder satellite observation satellite mission, will help us answer significant questions about climate processes by providing new information on clouds and aerosols. Dr. Stephens provided you with some information on clouds, so now let's concentrate on aerosols. What are aerosols? Aerosols are tiny particles suspending in the air. Some occur naturally, originating from volcanoes, dust storms, forest and grassland fires, living vegetation, and sea spray. Human activities, such as the burning of fossil fuels and the alteration of natural surface cover, also generates aerosols. Average over the globe, aerosols made by human activities currently account for 10% of the total amount of aerosols in our atmosphere. Most of that 10% is concentrated in the northern hemisphere. Can you think of a reason why? We have much to learn about the way aerosols affect global and regional climate. We don't know in what regions of the planet the amount of atmospheric aerosol is increasing, decreasing, or remaining constant. Overall, we don't know whether aerosols are warming or cooling the planet. So why do we care about aerosols? Aerosols tend to cause cooling of the Earth's surface immediately below them. Because they reflect sunlight back into space, aerosols have a direct cooling effect by reducing the amount of solar radiation that reaches the surface. It is thought that aerosol cooling may partially offset expected global warming that is attributed to increases in the amount of carbon dioxide and other gases from human activity. Did you realize if there were no aerosol in the atmosphere, there would be no clouds? What can you say about the relationship between clouds and aerosols? Aerosols are believed to have an indirect effect on climate by changing the properties of clouds. As aerosol concentration increases within a cloud, the water in the cloud gets spread over many more particles, each of which is correspondingly smaller. In this way, changing aerosol in the atmosphere can change the frequency of cloud occurrence, cloud thickness, and rainfall amounts. Also, clouds with low aerosol concentration and few large droplets do not scatter light well and allow much of the sunlight to pass through and reach the surface. However, the high aerosol concentration in these clouds allow for the formation of many small liquid water droplets. Up to 90% of visible radiation or light is reflected back to space by such clouds without reaching Earth's surface. Probably the best known evidence of the effect of aerosol in the atmosphere occurred in 1991, A severe volcanic eruption from Mount Pinatubo, Philippines, put an estimated 20 million tons of sulfur dioxide into the atmosphere. Aerosols from that eruption stayed in the atmosphere so long that average global temperature over the following year cooled by about half a degree. So earlier in the program, Jennifer was right that weather in the United States affects the weather here in France and all over the globe. And the reverse is true. Scientists have been observing clouds and aerosols globally from space for many years using sensors that measure the amount of energy leaving Earth. The sensors observe how clouds and aerosols vary with latitude and longitude, but provide little information of what is inside the clouds or on how they vary with altitude. For the first time, the Calipso satellite will provide vertical, curtain-like images of the atmosphere on a global scale using a Lidar. The Lidar technique is similar to radar in operation, but Lidar uses short pulses of laser light instead of radio waves to probe the atmosphere. The Lidar data from Calipso will allow us to determine precisely the altitudes of clouds and aerosol layers and the extent of layer overlap to identify the composition of clouds and to estimate the abundance and sizes of aerosols. Calipso gives us a highly advanced research tool to study the Earth's atmosphere, and will provide the international community with a data set that is essential for a better understanding of the Earth's climate. With more confidence in climate model predictions, international leaders will be able to make more informed policy decisions about global climate change. So the next time you wake up on a hazy summer day, you can tell your friends that the haziness may be caused by sandstorm or volcanic eruption that occur halfway around the world. Now back to you, Jennifer, et au revoir.